Have you ever done a science experiment and wondered what it'd be like if you did it big? I have. My name is Phil, and I take your everyday science experiments and do them big. This is Science Max, Experiments at Large. Science Max! This episode is all about mechanical advantage.
No longer will I suffer the weakness of human muscles.
Using the power of science to hurl pumpkins, pull cars, lift wheelbarrows, and, go back in time?
A trebuchet!
A what?
Trebuchet!
All on this episode of Science Max, Experiments at Large.
Behold, Science Maximites! I am Filtron 2.0! I have changed myself into a cyborg to give myself super strength! No longer will I suffer the weakness of human muscles! Behold my awesome strength! Tremble in fear at my might! I may have to give myself some upgrades. Yeah, so, okay. Maybe I'll just give myself super strength the old-fashioned way, using the power of science! Today is all about mechanical advantage, like this fulcrum and this lever, transferring a lot of force over a short distance or a little bit of force over a long distance, and vice versa. We are going to be building a trebuchet. A trebuchet. So a trebuchet looks a lot like a catapult, but a catapult uses elastic force to throw something, and a trebuchet uses the good old lever. There's a lot of weight on the short end of the lever, and on the other side of the pivot is the long end, and we've got a sling here with a marble in it, and we put that down here on the ground, and then we let it go, and whoosh, whoosh, it throws the marble. To build your trebuchet, here's what you need. Something to be your lever, like a pencil. Something to be your weight. I used batteries. You'll need to make a frame, and I use craft sticks and cardboard for that. A way for it to pivot, like a straw and a shish kebab skewer. Then you'll want a sling, which is a rope, and something to hold your projectile, like plastic netting. Finally, something to hold it all together, like glue. Get your craft sticks, make some triangles with one craft stick sticking up. Then get your craft sticks and make a base which you will put on with your cardboard like that. Now you'll also probably want to make some extra supports that go off the bottom there like that. Then get your pencil and cut a piece of straw so that you can see right through it, and you can get a shish kebab skewer and you stick it through the straw like that, and that's your pivot point, your fulcrum for your lever. What you want to do is put your weights, I've used some batteries, you can use anything that's heavy, on the short end of the lever. That's important because a lot of weight here translates to a little bit of weight going a lot faster on the other end. So, a lot of weight on the short end, and then on the long end of the pencil where the eraser is, you want to take a toothpick and stick it into the top of the eraser and then cut it off so it's just like that. That creates a little hook that you put the loop of your string net on so that when it gets flipped around, the loop comes off and then throws your projectile that way. And then, of course, you need something that you want to fire. I like to use marbles, but gumdrops work pretty well because they're nice and soft. And you put it in and you pull it all the way down, all the way so it's actually resting on the cardboard like this, and then you let it go. And it fires. And there you go, a trebuchet. Now, if you want to research how to build one of these yourself, it is called a trebuchet. Haha, trebuchet. Wait, I can make it come up, but I can't make it go away. I don't know why that works like that. Anyway. So we need to max out the trebuchet. Let's see, I need an expert. Oh, Chris. Chris from Logix Academy has a trebuchet. Maybe we can use that one to figure out how we can max it out. And of course, because it's a trebuchet and it's maxed out, we want to fire something, so I thought we would fire, pumpkins. Let's go. Good luck, little pumpkin. Hey, Chris.
Hey, how's it going?
Chris from Logic's Academy. I had a problem with the pumpkin. It kind of got larger than I expected.
It's okay, I think this one's bigger than what we need anyway.
Chris shows me a scale model trebuchet, one we can use to test a few ideas before building our maxed out version.
Oh,
and you've got little mini pumpkins!
I know, don't get too attached.
The first is the arm length, getting the right ratio. That means how long one side of the lever is compared to the other. When talking about a ratio, you write it like this, 1 to 2. It doesn't matter what the actual measurement is, just that this side of the lever is 1 of that measurement and this side is 2, or 2 times longer than this side. And it turns out a 1 to 2 ratio arm wasn't great.
Well, that could be better.
It could be better.
So we tried a 1 to 6 ratio arm. The 1 to 6 arm threw the pumpkin further, but not a lot further.
Better, definitely better.
Better? Then we tried a 1 to 4. Turns out 1 to 4 is the best arm ratio.
Whoa! That's pretty good.
Chris also had an idea about hanging the weights.
Because as you see here, these go straight down. And going straight down actually makes this spin even faster.
So when we do the big one, we should hang the weights off the end and not attach them to the end.
That's right, and that'll give you some extra distance.
Excellent. Let's fire this last one.
Okay, 3, 2, 1.
Whoa!
Pretty good.
Yeah. Okay, I wonder when we make the big one, do you think we can get it through the goalposts?
Oh yeah, I think we can do that.
All right, let's try it. All right.
This episode is all about giving yourself super strength using mechanical advantage. Well, here's how you can use a rope to give yourself the strength of a superhero. Ha-ha! I am mechanical advantage using a rope man. To gain mechanical advantage using a rope, you need 3 things. First thing, a rope. I mean, obviously, that's a given, right? You know you need a rope. Okay, good. Then you need something to pull and something that will not move. What you do is you tie your rope to the thing that you want to pull. Then you tie the other end of the rope, you guessed it, to the thing that won't move. Now, you pull from the middle like this. And it's very easy to pull the weight. Why? Because of mechanical advantage. You're using a small amount of force over a longer distance. But what if the weight is heavier? Then you lengthen the rope. Now we pull from the middle and it's easier. Why? Yes! Mechanical advantage. A small amount of force over an even longer distance makes it easier to pull the weight. Let's max it out. Mechanical advantage using a rope man, away! High above the city, mechanical advantage using a rope man surveys the town looking for someone in trouble. There's someone.
Oh, my minivan broke down and only 10 feet from my parking spot. If only there was someone who could help me.
I'll help you.
Mechanical advantage using a rope, man. I'm saved. Maybe you should try giving yourself some mechanical advantage using the rope. Mechanical advantage using the rope, man.
Yes. Well, I was coming to that. So I have this really long rope, and I tie one end to something that's not going to move, like a tree. Or a steel coil, if you happen to have one. And then I take the other end, and I run all the way back, and I attach this end to the van.
I call her Bessie.
Then I go to the middle of the rope, and I pull on it sideways like this, giving myself a huge amount of mechanical advantage.
Oh, it's working! It's working!
Pulling.
Mechanical advantage using a rope, man! You're doing it!
Ha-ha!
Well, gee willikers, you did it, mechanical advantage using a rope, man. You pulled the whole van.
And that's how you can use a rope to give yourself super strength. I am mechanical advantage. advantage using our rope man! Based on what we've learned from our small-scale trebuchet, Chris and I made a maxed-out version!
All right.
This, I think,
Wow.
is as big as we could possibly be expected to build this.
This is huge.
We have the length of our arm, which
Right.
is important.
Yes, and we've got to add weight here, so
Yeah.
we're gonna like loop this in. Whoa!
Oh, I guess that's because I took the weight off.
Yeah.
So, the arm is 4 times longer on this side of the lever
Right.
than on that side of the lever.
Right. So this arm goes 4 times faster than that side,
But
but we're gonna need a lot of weight.
like our small version, we needed to hang weights on the back of our trebuchet. So I got a rope and put some weights on. But because our new version is so maxed out, we need a lot of weight, which I needed to get on a rope and drag it over. Okay, almost there. And I needed to lift it onto the arm. I needed to lift it onto the arm. I lift it. You know, maybe we should do this together. And
Okay, you take one end.
and we lifted it.
That's gonna be a problem, Phil.
I'm kind of glad that happened because there was no way I was going to be able to lift that.
I know, it was way too heavy, and we need something stronger that can still hold the weight and still give us the hinge that we want at the top.
And once the weight's up there, if the rope broke,
That would be bad news.
that'd be big time bad news. Okay, so we need a new solution for getting the weights on the trebuchet that is not.
Not rope. We need something
Not rope.
stronger and hopefully that still has the hinge on it up here.
Maybe we have some sort of bar system that we could hang.
Yeah, I'm thinking metal.
Yeah, metal, definitely metal.
Definitely metal.
Metal is better than rope
I think so.
for holding a whole bunch of weight. Okay, let's
Okay.
get that done.
Let's do it.
All right, I got some metal over in the shop over here.
Okay.
Come on down to Sal's Science Shop. I am Sal, and this is my science shop. You want levers? I got the best levers around. Little levers, big levers, all drastically reduced. If you can find a lever anywhere else for less, then you gotta tell me, because I didn't know anybody else was selling them. Come on down to Sal's Science Shop, your one-stop shop for science. Hey, you want some levers? Well, boom, have I got levers. What class would you like? What's that? You didn't know that levers have different classes? Well, there are 3 different classes of levers. First class, business class, and coach. No, first class, second class, third class. It's pretty straightforward. And what do we need when we have a lever? We need a load, we need a fulcrum, and we need a lever. Ha-ha! First class lever. The fanciest of levers. You got your load on this end, you got your fulcrum right here underneath, and then you put some effort into this end, and wow! Look how easy that is. Ha-ha! First class. What kind of thing works like that? Oh, I don't know. How about this trebuchet you've been spending all this time watching? First class lever right there in front of you. Second class lever. Look, there's a load right here in the middle. The fulcrum's on this end, and you put your effort into this end, and you lift it, and look, it's a second class lever. Huh? How cute is that? But what kind of thing works like that? It's like a wheelbarrow. The fulcrum is the wheel. The load goes in this, I guess this is the barrow, and then I lift with the handles. Huh? Look at that. Ha! Lever! Third class lever. You got your load on this end, you got your fulcrum on this end, but where is the effort? The effort's in the middle, and it pivots while you move it. Huh? Huh? Where you gonna get that kind of crazy contraption? Salad tongs! Salad tongs! Salad tongs. Look, you put the effort in the middle there, it pivots on that end, and you have the load there. And there you go. First class, second class, and third class levers. Whatever your mood, we've got the levers for you. Chris and I had some trouble getting the weights on our maxed out trebuchet.
That's gonna be a problem, Phil.
So we had to come up with a new system. A metal bar that pivots on the bottom of the lever arm. It's got lots of spots for weights, and we could lift the weights one at a time to attach them all. We start out with 255 pounds. How many kilograms is that?
113.3 continues.
Yeah, that's what I got too. All right, that's definitely enough weight, right?
Definitely.
Okay, let's fire a pumpkin!
Let's do it.
This trebuchet works the same as the other models, but because it's so much larger, we really need to haul on the rope. We attach the arm to a quick release, which allows us to hold it in place until we're ready to fire.
Oh, here we go.
Okay.
3, 2, 1.
Whoa!
Oh!
Whoa!
We launched a bunch of the same size pumpkins and got a pretty good idea of how far we were throwing them.
Okay,
Wow.
you know what? We should leave this here so that we know how far that last pumpkin went.
And then try to beat it.
And then we try to beat it. We haven't gotten through the goalposts.
It seemed to handle the more weight pretty well. I think we can add even more. What do you think?
I think we should add all of the weight. This
Okay.
is Science Max. This is not like Science Minimum.
Let's max it out.
We
maybe.
totally maxed it out. Okay, all the weight.
All
the weight. All the weight.
Max Historica.
Good morrow to you! I am Lord Fillington IV, and welcome to my medieval castle! My father, Lord Fillington III, had his castle besieged by catapults, and he had to share his prized collection of snow globes. Well, I, Lord Fillington IV, have made a few improvements. First, was forgetting about snow globes. Those are so last season. I collect limited edition Science Maximals stuffed toys. And I've collected them all, and I'll never share. Hello?
That Lord Fillington has been hogging all the limited edition Science Maximals, and he won't even trade. I mean, look, I've got 3 floofers, and all I need is a Fricto. But he won't trade. Surely you can trade.
Never! I have all the Frictos, and I'll never trade.
That's it. Time to build it.
Oh, you're gonna build a catapult and knock my castle walls down? Well, I've learned a thing or two from my father. I, too, have catapults. Release!
Fortunately, we've got a new invention of our own. A trebuchet.
Oh, fiddlesticks! They have a duck pate.
Trebuchet.
A what? A Mother's Day? A Hudson's Bay? A
Trebuchet.
Cabernet? I can't hear you. You've got to come closer. Release!
The trebuchet was the best thing around right up until the invention of gunpowder. It could throw farther than anything else, even catapults. What you do, you see, is you put something in there, and then you put a big weight up there, right? And this goes down, that flies around and flies over the castle walls, all from far enough away where he can't get me with his catapults. And it works like this. 3, 2, 1.
No, didn't that make it? It's too high. It's too high. Ah! All right, I give up. I'll trade. Oh, that's quite nice. I like that.
Oh, and that's how trebuchets were used in history. Sort of.
Our giant trebuchet launched a pumpkin pretty far.
Very cool.
But now it's time to max it out further by adding even more weight.
All the weight,
All
all the weight, all the weight.
So we increased the weight to 425 pounds.
That's a lot of weight. Okay, are we ready?
I think so. I can't wait to see what this thing does.
I can't wait to see how heavy it is to pull.
Turns out pulling that much weight using our rope was really tough, even with the mechanical advantage of our lever.
There we go.
We found another pumpkin of the same size, but then we started having another problem.
3, 2,
2,
1, go!
Whoa! Look at how high it is.
One,
Whoa!
go!
Whoa!
One, so, I think we're going a little too high.
Yes.
It was almost straight up.
How far the pumpkin goes all comes down to when the rope slips off the pin at the end.
If the rope slips off too early, the pumpkin goes up and not very far. Too late and the pumpkin goes straight, which means it'd hit the ground sooner and doesn't go as far. A 45-degree angle is just right. And how do you adjust it? By simply bending the pin.
3, 2, 1.
Great. Great.
That went way farther than 60. We should have had another sign.
I don't even know how far that went.
Yeah, there you go. Science Max Experiments at Large, Trebuchet. So, one of us has to clean up the pumpkins and the other one has to put the trebuchet away.
Right.
Pumpkins!
Release! A little farther next time.
1.
Well, you're gonna have to throw it a little higher than that, aren't you?
There you go. Experiments at Large. I forgot the name of the show, so I figured, why not? Pumpkins! Almost dropped. Are you okay?